Myoglobin. Question 4. Myoglobin and hemoglobin are oxygen-binding proteins in mammals. The myoglobin molecule is a single globin polypeptide. The hemoglobin molecule is composed of both alpha-globin and beta-globin polypeptides. Okay. Myoglobin consists of a chain of 154 amino acids folded into a specific three-dimensional shape. Name a bond that holds the polypeptide chain in this shape. Okay, what I'm expecting is hydrogen bond. What I am mildly confused about in terms of the mark scheme is that I would also think it's perfectly valid to have said, you could have said ionic. I also, you might have seen disulfide bridges when you're reading about different things, and that would have been acceptable to me. And you could, bond-wise, I wouldn't go as far down as London dispersion forces. I'm only saying this for those who are doing chemistry because they're the ones who are likely to have gone with other forms of bond. But the only one they've got in the mark scheme is hydrogen. Now that is by far the most common one for an association to get the shape of secondary structure in a polypeptide chain. So just go with that. But as I say, I was quite surprised that they didn't have ionics, disulfides, hydrophobics, but this is what we have. So hydrogen bond, make sure you've got that one. Okay, the gene for myoglobin contains 1,154 bases, while its mature mRNA transcript contains 462 bases. Give a reason for this difference. I'm kind of surprised in some ways he gave me 2 lines for this because my first one to write down is just that you have RNA splicing. So RNA splicing has removed our introns. So I suppose, yeah, you could still run to the 2 lines. You could also have said that the 462 bases are the exons that have been retained during splicing. Okay. B. The genes for myoglobin and hemoglobin have evolved from a single ancestral global gene as shown in the diagram. Okay, so we've got our ancestral globin gene, and then we've got our alpha, beta, and myoglobin all shown. Okay, fair enough. In the genome of mammals, there are multiple copies of alpha and beta globin genes. The multiple copies of alpha and beta globin genes are the result of duplication mutations. Describe how a duplication mutation occurs. So when they're saying describe this, they're really just looking for a definition. So what you have is that a gene from the homologous chromosome is moved onto the chromosome, onto chromosome. Okay, so what we've got now is that we've got 2 copies of the original gene, the allele from the original chromosome and the allele from the homologous chromosome. Has to be homologous. Okay. Explain the importance of duplication mutations in evolution. This has come up several times, like the last 3 years basically it's come up, I think, in one form or another. Okay, so what we're looking for duplication is that you have one, at least, gene, which you can basically mess about with and alter, while the other one is still functional. Okay, so the one that you're messing about with, by mutation randomly occurring, might give you a better form of the allele. And if it gives you a better form of the allele, then you can keep it. And that's allowed you to muck about with it while you still had one that was good. Okay, so you have to put that in proper sciencey nice terms for the marker. So what you're trying to say is that you have one gene that can be altered while the other gene is still functioning as normal and so not affected by it. Okay, and that's the question.